Hello, my name is Xeni Demetrakopoulou. I'm from the Moraiti School in Athens, Greece, and I'm here to present to you a very unexpected paradox. It is based on the following problem. Imagine we have an equilateral triangle inscribed in a circle. This means that AB equals BC equals CA. What is the probability that if I cut the circle with this random chord, this chord is longer than a side of the triangle? Say AB. This problem was introduced by Bertnard in 1889, and this mathematician made 3 proofs, each one apparently valid, yet each one yielding completely different results. For our first proof, we will translate a random chord so that it begins at point A, which obviously belongs to the triangle. As you can see, if the second point of the chord, which we call D, lies on the arc BC, then AD is longer than the sides. But if D lies on the AB, or similarly on arc AC, the chord is smaller. And since arc AB equals arc BC equals arc CA, the probability that the chord is longer is equal to 1 out of 3. For our second proof, we will create a radius of the circle that passes through the origin O, through the midpoint M of this side, and let's call our third point of intersection with the circle E. We will now take for granted that OM equals ME. We can easily translate each random chord so that it is perpendicular to the radius and also cut it at point D. As you can see, if D lies on ME, the chord is smaller. But if D lies on OM, the chord is longer than the side. And since OM equals ME, the probability that the chord is longer is equal to 1 out of 2. But wait a second, what have we done here? We have proved that the probability can be 1 out of 2 and 1 out of 3 at the same time? To make matters worse, there is a third proof, a bit more technical, that states that the probability can also be 1 out of 4. And yes, this is possible, because in the world of mathematics, the phrase choosing by random is not enough. If we use and specify one selection method, we get one answer, as we did in each one of our proofs. But since there is no unique selection method, there cannot be a unique answer. In our case, we had 3 different answers, and therefore it is possible to have a probability that is 1 out of 2, 1 out of 3, and 1 out of 4 at the same time. Thank you.